switch off this from the socket. Let's check the board. Remove the block completely. Remove the head. It's removed from the head. Okay, remove the head. Try to program it. Let's see. Just remove the head. Nothing is hot. Everything is fine. No, it's not modulated. To still do the same thing. Okay. Now, just to draw your attention once more, what we have right now is what we call the solid state relay. So the solid state relay here on board is made up of a triac. Here we're using a BT137 that can withstand at least 4 amp and up to 600 volts. It can tolerate. And then we're using an optocoupler, 3045 or so with a zero crossing capability. The optocoupler isolates the high voltage from the low voltage of the board. So this is actually the circuit here. Very, very tiny. And then we have some filters here, capacitors, and as numbers. Now I want to draw your attention now to other connectors we have here. Here we have a set of black connectors. There are 5 in number: 1, 2, 3, 4, 5. These very ones now can handle mechanical relays. So in essence, you could connect up to 5 different mechanical relays here to do the same switching for you. They could do up to 8 amps or whatever the rating of the relay is. This is a mechanical relay over here. More so, the same connectors there can be used for your DC motors. You can also use it to control motors as well. You can also use it even to control stepper motors. Maybe unipolar stepper motors can also be controlled here. You can even use it to control servo motors of a higher voltage or what have you. So it's quite multifunctional, absolutely. Yes. No? So the SIM, GSM GPRS module here, bypassing the microcontroller. So your computer now is talking directly to your SIM. So you can actually use your hyperterminal now to configure the SIM. You can change the baud rate if you want, other features you want. Now if you have your SIM card, let's try to make a call from the hyperterminal now. We should be able to call a couple of more. So we need I think it's a micro SIM it uses. Yes. Can someone volunteer a SIM card? So we'll slot it in here, and then straight from the hyperterminal now we'll call anybody's line. Then we can also send an SMS. That shows how flexible the board is. Meaning that the microcontroller can talk to your module, okay, by using your jumpers to select which of the channels you want to communicate. Also, you can talk to your you can talk to your GSM GPRS module straight from the PC using the hyperterminal. So that shows, how flexible this very Unity board is when it comes to interfacing. It's really, really flexible, and it gives you that possibility for endless hacking with minimal wiring or minimal breadboard. So I'll be showing this soon. What's that? Now, Chima, is your SIM card, micro SIM card? We've put in the SIM card. Now it is flashing twice a second. So as soon as it hooks onto the network, it will be flashing once a second. So pay attention to the red light on the SIM module. So right now it's trying to get a network. As soon as we are hooked onto a network now, it will start flashing once a second. Is the network here very good?
Yeah, everything is good.
Are you sure that the SIM is in the right position? Alicia, I'm just asking. You're still taking time to. It's not the other way around here. I'm just thinking. Problem here. So can you dial an ATD? No, you're not putting plus. There's no plus there. ATD, D.
I'll just
080-807. Okay, you already removed this. Use 80. Use 80 to be sure it's hooked up to the board. Okay. 0807. Okay, you're using my phone. Whose number is free?
081.
081.
87. 63. 7000.
7,000. Finish, have you?
Yeah. 081.
No. You are wrong. You are wrong. Very, very wrong.
081. 87. 63.
You have to put semicolon at the end.
7000. 000. 7000.
Semicolon at the end. Semicolon, wait. Then copy it. So you don't have to retype it each time. Copy it. It says you're not attached. Just copy, let it be in the buffer. Okay, fine. So then send, let's see. Okay, fine. Drop your phone here, let's see when it is ringing. So right now I try to ring a phone using hyperterminal. This is the phone over here. So let's see if the call will come through. We're watching out to see if so it's ringing, as you can see. So directly from the hyperterminal, we're already ringing this very phone. So in essence, it's a Unity board that is calling this phone. Now type in ATD. Sorry, ATH. ATH now will drop, so it goes off again. Okay, can you repeat the calling again? You have to show how it's typing in there. So this is the hyperterminal, which is what we call the serial monitor of our Arduino IDE. So I've typed in the number we want to call over here, and then we're going to press enter. So the Unity board now will be calling this very phone now. Let's watch and see. This is the GSM GPRS modem here, flashing. So waiting for the call to come through. So already is coming through. Now the beauty of this very application is it could be channeled towards your tracking system, your alarm system. Various areas you can actually use it where you want to be alerted of you want to have an alert of a particular whatever. So the applications are numerous. The same way we can send an SMS also. So the Unity board can give you a call. It can also send you an SMS. Okay? I think this is clear now. Yeah. Now what we did is I think we should come closer. Let me try to explain this part. There's no light. I wanted to have more light here. Okay, just flashlight here because of my side. Let's have light by the board. Beautiful. Just put it. I need something like this pen to be pointing this down. Now if you put out the communication here. Now if you look at the communication, let me start from here. Put the light here on top here. Because I have the USB TX, okay? USB RX. So the middle pin, let me get out the jumper. I'm getting out so let me get out the jumper now. So the jumper. So all these yellow pins are the communication channels. They connect to your Bluetooth or your ESP, that's the Wi-Fi module, or your GSM GPRS module, or your USB. That's basically what this communication channel does. And it's very, very flexible. Now the first channel here, that's the first group of 3 pins, is called the USB TX. So in essence, the middle pin is the TX transmit pin of your USB. It's USB, that's the transmit pin, and over here the middle pin is your receive pin. Now the first pin here is your microcontroller hardware serial port. In this case, it should be our RX. Yeah. So the first pin here is your receive of your microcontroller, receive pin of your hardware serial port of your microcontroller, and then here is your transmit pin of your hardware serial port. Now, if I want the USB now to talk to the microcontroller through the hardware serial port, all I have to do is to take this very jumper, connect the two together. That means that the USB, that is the middle pin, TX, transmits connected to the receive pin of the microcontroller hardware serial port. The same way I'll do here for the RS of the USB connected to the TS of the microcontroller. So this very position, I could actually upload my code onto the microcontroller. The microcontroller can directly communicate with the hyperterminal here, because it's already connected to the hardware, and then to the converter, then to the system. I think it is clear. Yes. Now, if I want the USB now not to talk to the microcontroller, I want the USB. When I mean USB, I'm actually talking about the PC, because the USB goes all the way to the computer here. Okay? It can be any program running, not necessarily only Arduino IDE. I could connect the normal hyperterminal that is window-based. I could connect to other serial programs, maybe on C# or what have you. It actually communicates, so long as I maintain the baud rate and other parameters that are necessary. Now, I want, for instance, the computer to talk directly to my GSM GPRS module. In this case, we are using SIM800L on the board. All I have to do now is that I go back to the board, remove the 2 jumpers again, identify what I have here. Okay, what do I have? Okay, the second pin is actually what? SIM. Yeah. RX. Oh, beautiful. So I have an RX, so that means that the TX of the USB goes to the RX, obviously. So I put it in the second position. The same thing goes automatically. Second position here.
Okay.
So I can directly now communicate with my SIM module from my PC. Am I making some sense?
Yes, sir.
Now, what if I want to communicate? What if I want the microcontroller now to talk directly to the SIM module?
So that means what?
You have deployed your application standalone. You don't need a computer anymore. I want your microcontroller now to be sending the whole AT command, which is actually the case. How is that done? Come over here once more. You will see SIM RX here.
Yes.
SIM TX. Am I right?
Yes, sir.
If you go to the pin side, what are you looking at? Is there any RXD somewhere at the pin side here? Check any of the marking. There is RXD. Can't you see it's tiny? RXD. Look at it. The first pin here is RXD.
Yes.
The second pin is what?
TX.
As we mentioned, wherever you have your RSD, TXD is actually referring to the hardware serial port of the microcontroller. So what do I do here? I need to just remove this, transfer it here. And we transfer this here. Straight. Sorry. Yes, correct. So in this very position of this jumper, that means that the microcontroller can communicate directly with the SIM card. Directly. It doesn't need hyperterminal. Okay, now let's look at another situation. Okay? I'm programming a code to the microcontroller. I'm uploading a code. Am I right?
Yes, sir.
To this very device. So my hardware serial port of this is occupied. I can't afford to have SIM module to be connected to it. Am I right?
Yes, sir.
Because all your uploading of code goes through the hardware serial port of the microcontroller. That means that I have to bring this back to the hardware